I didn't check for symmetry, but obviously it's not going to be symmetric. That's all I care about. Let's do this together. I start by plotting the points I have. You can say, and I will agree with you, I don't have sufficient points. I want to find 5 more points. Go ahead. I'm fine. It's okay if you'd like to. There is no need. I don't want you to work too hard on these problems. So I will have to plot negative 3, 0. Is it clear why this is negative 3, comma 0? Yes. 0, comma 0, and 1, comma 0. Ready? So let's read the table. It's coming from negative infinity, and it crosses normally at negative 3, 0. It has to turn somewhere, but because it comes back at 0, 0 and crosses, but not like this, but like this. Then it has to have a turn at 1. Well, it must have a turn already here so that it can turn again and go to negative infinity. So let's do this again. Let's write f of x equals negative 3 x cubed x minus 1 squared and x plus 3. Let's do this again together, and then we check with the graphing calculator. It's not a good idea to check with the graphing calculator before you discover this on your own. Okay? So let's do this. It's coming from negative infinity. It crosses normally at negative 3, 0. I know it has to come back and cross flat at 0, 0, so then it has to have a turn. It comes back, crosses at 0, 0, flat, but I have to come up to 1, 0, that is a turn, so it has to come to a minimum again and turn again at 1, 0 and go to negative infinity. So let's put this in the graphing calculator and see what we get. In y equals clear, and we have negative 3 x cubed, in parentheses x minus 1 squared, and in parentheses x plus 3. So I've graphed it. I'm going to use the standard viewing window, although I have no idea how high this is. I have no idea. It may be outside of the viewing window. It may be, I don't know, 50. So then 10, negative 10, 10, and negative 10, 10 will not show. So I'm going to use the standard viewing window for now. So zoom 6. So as expected, it's coming from negative infinity. Look at that. It's completely out of the viewing window. But it's very clear that it crosses at negative 3. It goes to a maximum, comes down and crosses flat. This is not the same type of cross. See? Here and here, not the same type of cross. It's coming to a minimum, turns there, the minimum, right? And turns again at 1, 0. In order to show this and find it, I have to go to Window. I'm going to change between negative 5 and 5 because there is no action outside of negative 5, 5 for the x with a scale of 1. But obviously, for the y value, the minimum, it's okay. I can even change the minimum to negative 2. But the maximum is not okay. I don't know. I'm just going to put 100 with a scale of 20. See what happens. So I have negative 5, 5, 1. Negative 2, 120, 1. Well, just 20. And now I'm going to press Enter. Oh, I meant the graph. Still not good enough.
Dang. More than 100?
Okay. So I also want to see this. So I'm going to go back to Window. This time I'm going to put 500 with a scale of 100. And y minimum, I'm just going to say negative 50. See what happens. And graph again. Much better. However, because of the change of the scale, I'm able now to see this maximum, but I don't agree with this. Right? It cannot be on the x-axis. But because of the scale, you have to be very careful. That's why we have to graph it first. We know what to expect, and we know that this is lying to us. It must be a minimum, and we'll find it in a minute. But let's find the maximum between negative 3 and 0 first. Negative 3. So go to second and calc. And we want to determine the maximum. So we choose number 4. It's asking us where. We're going to say between negative 3, enter, 0, enter, and enter again. And I get the maximum, which is negative 2.4. And I put it in my table. Negative 2.4, 289 approximately. Do we get this?
No. I can't.
Did you go to
Second
and
count and then number 4.
Yes. Oh, but you have to see it. I don't think that it will give it to you if you cannot see it in a viewing window. So for the window,
Change it to all that stuff.
yes, yeah, because I think it's not going to show it to you. It's not going to give you the answer if you cannot see it. I don't think so. So we got negative 2.4, everyone. Negative 2.4, comma 289 roughly. Can anyone confirm? Okay. Now let's change the viewing window in order to see this minimum that we know it's there. Are you okay, Charisse?
Yeah, I'm fine.
You need more time?
No, go ahead. I'll figure it out. It's okay.
You did?
No, I will. I'll figure it out. I don't know what I did wrong.
So let's go to window. So this was negative 5 to 5 with a scale of 1. That's okay. And minimum was negative 50. And the maximum was, I think I put 500. And with a scale of 100. So now we graph. It's coming. Let me just see the function. Oh, you forgot to put x cubed. Negative 3, you have to insert. Insert. Second and insert. And you need the power. It's x cubed.
Okay.
Yeah. So let's change the viewing window now. I'm interested in this piece only. So I'm going to change the viewing window from negative 1 to 3. A scale of 1 is fine. Y minimum, negative 5. Y maximum, 5 with a scale of 1. And graph. It's coming. It's excellent. So it's coming from that maximum value. It crosses flat. It comes to a minimum. It goes up to 1, 0, where it turns and comes down to negative infinity. So now I can determine this minimum between 0 and 1. Second and calc. I want the minimum now between 0 and 1. And I get 0.61. And I put in the chart 0.61, negative 0.4. And now we know everything about this function. There is one other item that we do not know, but we can determine it. And it's not part of this course anyway. Now I would like to illustrate with the word problem, because I'm sure you're asking yourselves, okay, fine, that's wonderful, but where do I use this? Any questions before we do that? Any questions? Okay, so let's take a look at this graph. Excellent. Let's read it. Little problem. It's 75 on page 380. Problem 75 on page 380. During a diagnostic evaluation, a 33-year-old woman experienced a panic attack a few minutes after she had been asked to relax her whole body. The graph shows the rapid increase in heart rate during the panic attack. Okay. Part A. For which time periods during the diagnostic evaluation was the woman's heart rate increasing? Between minute 1 and minute 4, and between minute 8 and minute 10. Remember, we discussed that, not from which value to which value, but for what time frame. Part B. For which time periods during the diagnostic evaluation was the woman's heart rate decreasing? Very good. Between 4 and 8, and between 10 and 12. Awesome. How many turning points occurred for the woman's heart rate during the first 12 minutes? So a turning point is from increasing to decreasing, from decreasing to increasing. How many turning points? Yes. 1, 2, and 3. 3 turning points. Up, turn, down, turn, up, turn, down. 3 turning points. Suppose that a polynomial function is used to model this data. What would be the degree of the polynomial? Exactly. Why 4? Because degree 4 will have 3 turning points. But what about 15? Even 15 can have 3 turning points, but the minimum degree is 4. Correct. Excellent. Should the leading coefficient of the polynomial function be positive or negative? If it's positive, then it has to look like this. 1, 2, 3. If it's negative, then it has to look like this. 1, 2, 3. Of course, negative. Right? Up, down, up, down. If it has to turn, then there are more turns then. If it goes up, 1, 2, 3, 4, 5. 1, 2, 3. Is that better? Perfect. Use the graph to estimate the woman's maximum heart rate during the first 12 minutes. Yes, I would agree with 115. Use the graph to and when did that occur? 10 minutes into the test. Use the graph to estimate the woman's minimum heart rate. Yep, 63, 64, something like that, maybe 65. I agree with that. When did that happen? Good. Very good. So this is a typical situation in which a polynomial degree 4 would have represented the data. Very good. Questions? Questions, please. Okay. Well, we'll have other examples when we review for the test, and if you, I'm hoping that you're going to work on more. When we review, we can pick other problems, or if you want, we can pick other problems. Now it's up to you. Yes, which one? Which type?
Let's do the first time we did like a problem.
Odd, very good. So f of x. Let's look back at odd. So let's choose a problem.
Is it? Can we see? Like, is it possible for? I don't know if everyone would agree to try to do it without instruction.
I don't really want to do that.
You don't. You just want to do it.
Yeah,
Oh, okay. All right. What was in the
It's because you want to see a second example before you feel more comfortable with it?
Yeah.
Okay, that's fine. So we said odd degree. Perfect. Here it is. 42 on page 378. X cubed plus x squared minus 4x minus 4. What is the degree of this polynomial? Yes, so the degree is? Good. Maximum possible number of turns? Two possible turns. It doesn't have to turn at all.
And the degree is 3 because it's the highest power up there, right? Is that what
That's how we determine the degree of a polynomial, the highest exponent, yes.
What about the X-intercepts?
We didn't get to that yet. Yes, that's the next step. Very good. X-intercepts. How do I get the X-intercepts? I was going to ask the domain to put it in the table, but X-intercepts are fine. The order is not important.
So how many turns? 33?
So yes, 3 X-intercepts.
So
What is the domain?
Maybe it's 32.
Of course, it's a polynomial function. Good. So how do I find the X-intercepts? Very good. So then I have x cubed plus x squared minus 4x minus 4 equals 0. Remember, whatever I get, it will become a 0 as the point, correct? Perfect. Good. So what type of polynomial is this? We solved these equations in chapter 1. That's why I'm begging you to redo your test every weekend. How do we handle this? By? Thank you. From the first two, what would you factor out? What is left in parentheses? What will I have in parentheses coming from the other two? And I have to have 0. I'm not making this up. I do not look at the other two before I write this, the equal symbol, and 0, because I may mess it up. So what is this? -4. Excellent. Perfect. So then we continue factoring out. Excellent. And then, very good. How do I factor x squared minus 4? That is a trinomial. This one is a binomial. No, I can't yet. X minus 2 and x plus 2. Please review factoring, please. How many solutions we have to establish for sure? 3. Please give me 3 solutions. Multiplicity for all of them.
1, and 1.
Very good. I go back to the table and I put -2, -1, -2, -1. 0 must be in the table at all times. So I put -2, -1, and 2. -2, -1, and 2. What do I write under -1, under 2, and -2? 0. Do we agree with this? Perfect. Now let's plug in 0. 0, 0, 0. So f of 0 equals -4, which is the y-intercept.
What happened?
We have to plug in 0, 0, 0, 0, -4. So f of 0 is -4. So we determine the x-intercepts, and this is the y-intercept when we make x equal 0. What do I have to write on top of -2, 0, -1, 0, and 2, 0? Exactly. Plain, simple cross. That's my note to myself. I only need the end behavior and we're done. We know that the degree is 3 and the leading coefficient is positive. So does it look like this or does it look like this? Number 1, or number 2? Of course. That's it. From negative infinity to positive infinity. The degree is odd. It has to look like the linear function with a positive slope. We're done. We're ready to graph. Once you have the table filled out, you're done. You can find any other points if you'd like. Yes, Rachel?
Quick question.
Yes?
Because in the last problem, we added the 3 and the 2 and the 1.
You mean the max? Are you talking about the max min?
Not for the x, for the degree. And over here, the degree was 3, like the x cubed and x squared.
Right, but I don't have a product.
Um,
Right? Very good point. Very good point. Here I'm not multiplying.
Gotcha.
Here I am multiplying. When I multiply x cubed by x squared from here, I will get x to the 5th.
Then you add the x.
Yes. So when I multiply factors, I copy the base and add the exponents. But here there is no product. Here I had a plain polynomial. It didn't come from product of factors. It was just a plain polynomial, and we had to factor it. So see, when I factor it now, I get the same thing. X times x times x. Copy the base, add the exponents. Degree 3. Better?
Yeah.
Very good point.
I just get mixed up.
Very good point. So now I have the table. That's all I need to graph. Ready? Nothing else. We plot the points. The points I have to plot are -2, 0, -1, 0, 0, -4, and 2, 0. So -2, 0, -1, 0, 0, -4, and 2, 0. Ready? Okay. So let's read the table. The function is coming from negative infinity, and you will cross at -2, 0. It's coming from negative infinity, and you will cross at -2, 0. Right? Coming from negative infinity and crosses at this point. Keep in mind that it has to cross again at -1, 0. So it has to turn, so it can cross again. This time at -1, 0. Now it has to reach the y-intercept. I have a problem with that. Because it can do this, it can do this, or it can do this. That part I don't know. College algebra doesn't have enough tools. We do this in calculus, for example. But let me just give you a hint. Here's the hint that I'd like to give you. Polynomial functions are continuous, very smooth functions. If I have to turn twist my wrist to graph, that's not right. So if I want to do this, I will twist my wrist. This one it's better. This one, I would say it's even better. But this one is I have to, this cannot be a polynomial function. So I would say this is not an option. We'll check with the graphing calculator. We'll do that with the calculator, not by hand, really. So, and then, but I just wanted to give you a point. So, a pointer. So 2, 0, crossing at 2, 0. Either this or this. Cross normally and go to infinity. Again, I believe that it's going to be this. You don't have to change anything. You just show me that and I'm fine. So let's punch it in y equals. Clear. So we had x cubed. And then plus x squared. Minus 4x. And minus 4. Let's go back to the Zoom 6. because we had something else in there. Let's see what happens. Okay, so it's coming from negative infinity. It crosses a negative 2, 0. It has a turn. It comes back to cross again at negative 1, 0. It crosses at 0, negative 4. It continues as I was expecting, because otherwise I would have done this, and that's not a polynomial function. It has a minimum on the right-hand side of the y-axis. It crosses at 2, 0, and goes to infinity. Everything pretty much as we expected it to be. What we don't have is the maximum, the minimum. So let's determine them. The maximum is between negative 2 and negative 1. So second on calc, maximum is 4. Between negative 2, enter, and negative 1, enter. Yes? Uh-oh. I did something. It probably didn't take the minus. So minimum, we want the maximum. Yes, we want 4. Okay, I want between negative 2, enter, negative 1, enter, and enter.
It was 2x.
What am I doing? So I want the maximum, which is 4. I want the left bound to be negative 2, please. I want the right bound to be negative 1, please. And just give it to me. Okay, negative 1.5, 0.88. In the table. Where's my table? Negative 1.5 and 0.88. So this is a local max. I put it in. Now I want to determine the local min. I see it's between 0 and 2. So second on table, second on calc, I want a minimum, which is 3. The left bound is 0. The right bound is 2. Give me a minimum, please. No guess. So 0.87, negative 6.1. 0.87, negative 6.1, and this is a local min. You do not have to adjust the graph. I'm fine if you just show that, but you do have to write f of x equals x cubed plus x squared minus 4x minus 4, somewhere on the graph. And this is my table. I put in the local max in here, where it belongs, and I put in here the local min, where it belongs. Do you feel a little bit better about polynomial functions?
Not really.
Well, it takes a while. We have not seen these kind of functions before.
I mean, I feel like I don't know like this chart. I don't know how to do, but I can use the hell out of it.
So use a different chart. Create your own. Summarize the information, because if you have it spread all over the place, you are not going to be able to graph it.
Is there just like a better way? Cause like when I'm like shoving in this like local max and min into my thing, it's just like maybe I'll just make it bigger or something. I don't know.
Yes,
It's just-
yes, I would recommend make it bigger. I didn't know what the max
Yeah,
min.
and that's what, yeah.
Yeah. So I would, if I were you, I would rewrite this and make it nicer. But what does this chart say? It says that x can be anywhere between negative infinity and infinity. And the points, the x values that I'm interested in are negative 2, negative 1, 0, and 2. Then I put the values underneath, because these are the points, negative 2, 0, negative 1, 0, 0, negative 4, and 2, 0, x and y. And then the end behavior. And then all I do is I look at the values of y coming from negative infinity and crossing at this point. Then it has to come back and cross, so there must be a maximum in between. And so on and so forth.
Would it help if we can, is it called interval notation? Or just sets? Can we just write the points out? Would that be like helpful?
You can if you want, but putting everything together may be difficult. It's up to you.
Maybe like just, I mean, well, I get it this way, like the points. But maybe if you write them on the side, like -2, 0, -1.
Yeah,
0,
we can
so you'll
do
know
that
where to graph
here.
it at.
Yeah, we can do that here. -1, 0, 2, 0, -2, 0. And 0, -4 was a y-intercept. Yeah, of course. 0, -4, -1, 0, 2, 0, and -2, 0. Yes, of course. That's not a problem. And that's what we have in the table. So -1, 0 is this point. 2, 0 is this point. -2, 0 is this point. And 0, -4 is this point. I put them in order from left to right. You can make a vertical chart if that helps you, if that's better. Or you can summarize the information in some other way that you would like. That's fine too.
I just don't get the can you just go over like the how you would know if it's up and down one more time? And I'm just gonna write it.
You
So
mean
I-
how to read this into the graph?
yeah.
Okay, so I'm looking at negative infinity. Negative infinity.
Right.
And it crosses at -2, 0.
No, I'm sorry. I mean like the crop the
You're talking about the end behavior, right? It's a,
yeah. So you said like negative coefficient
And
and
odd,
and
an odd degree.
So,
But you don't have to write it. If you copied this, you have it in your notes already. But if you want to copy it again, so it's already in your notes. If the degree is odd,
the end of
and the
behavior
leading-
chart that you wrote.
yeah. So that's the end behavior. If the
But
degree is odd and the leading coefficient is positive, it looks like this.
odd degree, like the number, like 3
Degree
Odd
3, degree
numbers.
5, not odd numbers.
I mean
The
odd-
odd degree.
odd degrees.
Yes, like what we had degree 3. Degree 3 is an odd degree.
Okay.
So in our case, the leading coefficient was positive, so that's why the behavior was this, negative infinity to infinity. Degree 3 and a positive leading coefficient, negative infinity to infinity. If you want to write it again, we can.
Okay. 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 Odd
So
coefficient would
if the degree were
be
3,
less than
but the
0.
leading coefficient negative, I would have written positive infinity and negative infinity.
I keep forgetting that the A
A
less
is the
than
leading
0.
coefficient.
I keep forgetting that A is less than 0 means it's a negative number.
Oh yeah, yes,
That's-
yes.
okay.
A less than 0, the leading coefficient is negative.
All right.
A greater than 0, the leading coefficient is positive.
Okay.
Is that better?
Yeah, I got the chart written down.
Okay. Well, as I said, this is not a trivial problem. This is not a trivial problem. I'm trying to make it look easy, but it's not a trivial problem. So it takes time. I don't want you to work too hard on it. I don't want you to determine too many ordered pairs because that will take a lot of time. So that's why I was hoping that once you go back and redo these problems, you will feel a little bit better.
The test is next week, right?
No,
Oh, okay.
no, I have to finish chapter 3. I haven't finished chapter 3. No.
How many more parts to check?
We have 3.3, which is division of polynomials, and we have 3.5, rational functions. Rational functions are even more sophisticated than polynomial functions. So it's all this plus some other items that polynomials don't have. And then the inequalities are very simple, I think. They will be very easy. They are very visual, so
Oh, this is it all
that's
graphing?
section 3.6.
It's not all graphing though, right?
No, we are not graphing those.
Okay, just solving.
Solving inequalities. Yeah, so what we're going to do